Hi guys, new chapter today. We're starting chapter 4, which is all about the periodic table. We're going to cover section A today, okay? So a little background first, a little history. Way before there was ever a periodic table. This is back, in the time of philosophers, before we even had scientists. Some of the philosophers thought that these were the only elements in existence in the universe. There was earth, basically ground, dirt, fire, air, and water. And eventually, Aristotle, who was a very famous philosopher, he added ether. And the ether was the idea of just basically the universe, kind of the stuff out beyond Earth, okay? Well, then eventually we got some actual scientists, although they were doing kind of weird stuff as well. Early scientists studied something known as alchemy, and their whole purpose, their whole goal was to turn ordinary elements into gold. Okay, so it was a bit of magic, and fantasy involved with this, and turns out it's not possible. You can't actually turn known elements into gold. It kind of stands to reason when you think about all the elements just having a different number of protons. If there was just a way to remove some protons or add some protons, you should be able to make gold, but it just doesn't work that way. Those strong forces between those protons in the nucleus of the atoms just doesn't allow that to happen. Eventually, this developed into chemistry itself, which is just the study of elements and compounds. So all these elements on the periodic table are what gets studied, and how they react with each other is what gets studied with chemistry. Okay. Robert Boyle is an old-time scientist, and he was one of the first to really start experimenting with these elements, but also just the idea that this experimentation should be the basis of science. Really starting to shift from that idea of philosophy into actual empirical science, where you're experimenting and you're making observations and then determining things from that. Another scientist, his name is Anton Lavoisier. He was around in the late 1700s. He is the guy that kind of came out and said, you know what, fire is not an element. Simply because it needed oxygen in order to burn, which told them that it wasn't an element itself. Okay. Water obviously is made up of elements. Earth is made up of different elements. Air is made up of elements, but fire is actually considered energy. There's some gases involved to it, but it's not really its own thing. Okay. And then finally, this dude named Jacob Berzelius, he came up with the naming system for elements and the symbols we use today. And a lot of them actually come from the Latin word used for those elements, right? But the real guy that gets credit for this periodic table is this Russian scientist named Dmitry Mendeleev. And he's the one that first started noticing that there was a lot of patterns in the elements. The whole reason the periodic table is called the periodic table is because things happen periodically. There are patterns with all of these elements. He created the first periodic table back in 1869, and this is it right here. It's nothing more than a list with some numbers next to it, okay? He originally organized these elements according to their atomic mass, okay? Remember, the atomic mass is the average mass of all the isotopes of an atom, okay? And it's not bad. If you look at today's periodic table, for the most part, the elements do go in order of increasing atomic mass. There's a couple of exceptions, though, okay? He also looked at their bonding power, kind of their reactivity with each other. Today's periodic table is organized by atomic number. Remember, that's the number of protons in the nucleus of the atom. Now, the fascinating thing with his periodic table is if you look, you can see some question marks, okay? He was confident enough in his elements and these patterns that he was finding that he knew there had to be something between zinc and arsenic, okay? And he could guess about what their atomic mass would be. Those hadn't been discovered yet. He didn't know what those were called, but he knew there had to be something there. And he was right, okay? He was right. Not bad for 1869. Again, we've already talked about atomic mass. That's the average mass of one atom of an element. but it's really the average mass of the different isotopes of that element, okay? All right, so the modern periodic table looks more like this, okay? And one thing to keep in mind is these guys down here actually fit right up inside of here, okay? So this is kind of a little breakout section. And the reason for that is it just keeps the periodic table a little more compact, okay? Let's see. So in 1914, X-ray spectroscopy, which is this super high tech, even for back then, method of determining what's happening with the electrons, what's happening with the protons in these atoms, and that's what allowed these scientists to determine definitely the number of protons in each of these elements, okay? So the atomic chart of the periodic table was rearranged according to that atomic number. We've already talked about that in class. You see the number that helps identify those elements. That is equal to the number of protons in each of those elements, okay? Periodic law states that properties of the elements vary in a periodic way. So as you move over or as you move down, there's going to be some patterns, okay? And we're going to talk about those in a later lecture. There are a total of 118 elements on the periodic table today, but a lot of those, and in fact, if you look back here, all of these orange elements on the bottom and then down there, so really starting at about 104, those are all synthetic elements. Those elements only occur in the lab setting, and they're so unstable, they only exist for a fraction of a second. They do not occur in nature at all, okay? All right, so let's talk about the organization of the periodic table in general. We have these things known as families or groups, which are the columns, okay? So that's the vertical columns. A set of elements in a group or in a family have very similar properties, very similar characteristics. So really when we're looking at elements that are in the same column like that, we can tell a lot about those elements. And the reason for that is because they have the same number of valence electrons. Now, valence electrons, remember we talked about the electrons kind of orbiting around the nucleus of the atom. The electrons occur in different energy levels, okay? There's only 2 on the innermost layer, and then there's a different amount on outer layers. But these electrons really like the number 8. Okay, so the outermost shell of the electrons is known as the valence shell or the valence orbit. Those electrons that are taking up that outermost ring, those are known as the valence electrons. And those are the electrons that are either being shared and given to another element, or extra ones are being brought in an attempt to stabilize those electrons. And then that's how some of these elements combine and form compounds, okay? All right, then a period is a row. So that, the horizontal rows, that would be a period of elements. And those are also numbered. Those really don't have a lot of properties in common. However, they do share that outermost ring, okay? So they have the same energy level. So for instance, these 2 elements in the first period just have that single energy level, that single orbit of electrons, and it only holds up to 2 electrons. Then these in the second period have an additional ring. And so each period we move down, we're adding an additional orbital ring for those electrons, okay? I guess that's it. Whew, that was a quick one. All right, we'll talk more about the periodic table next time. See you later.